Okay, this is on similar polygons. Okay, on similar polygons, we have spent a good share of time going through congruent polygons. Congruent polygons have the same size, same shape. All the angles are congruent, all the lengths are congruent. This is a whole different thing. This is similar polygons. So I want to go through definition, then I'm going to go through an example. Okay, for a similar polygon, it's when polygons have the same shape but may be different in size. And two polygons are similar IFF means if and only if they're corresponding two polygons are similar if and only if their corresponding angles, okay, and you can just use the symbol for angles, their corresponding angles are congruent and the measures of their corresponding sides are proportional. Okay, so these shapes are going to look, they're going to look similar, they're going to have congruent angles, but the sides have to be in the same ratio. They are proportional. Okay, there is a new symbol. Okay, when I say the word similar, okay, this was the word, this was the symbol for, when we did this, this was the symbol for congruent. There is a shortcut symbol for similar. It's just the curve. Okay, so that means they are similar. Okay, I'm gonna show you an example. And I noticed in the notes some of you are not drawing the pictures. You need the pictures. Okay, the pictures that's what makes sense in the examples and the problems. So I'm gonna draw. Hang on. Say I draw an object like that. Okay. And the advantage of the computer is, okay, to copy it, paste it, and now I just made a similar figure. Okay, that's the advantage, and you could do that if you were on your iPad. Okay, so label this angle A, down here B, C, and D. Over here label this one E, F, G, and H. Okay, now remember we draw the symbols to mean these angles are congruent. So this angle A is congruent to angle E. The angle, like if this was a, say an 80-degree angle, then E is an 80-degree angle. They are the same. Angle B is the same or congruent to angle F. Angle C is congruent to angle G. Okay, and angle D, need 4 curves there. is congruent to angle H. Okay, so in similar figures, these are not congruent figures, these are similar. Similar figures have congruent angles and their sides are in the same ratio. Okay, so let's say this one is 5, and these are all in meters. Say this one is 6, BC is 6, CD is 8, and AD is 10. Okay, and let's say this one is 2.5, FG is 3, GH is 4, and EH is 5. Okay. Now, if you looked at these, AB to EF, AB is 5, EF is 2.5 if you reduced it. 2.5 goes into 5 twice, and into EF would go in, 2.5 would go in there once. If I did BC is in a ratio or proportional to FG, okay, and it's 6 to 3, and all of these have to be the same. They all have to reduce. CD, the order that I'm writing these should be the same, like CD and GH, and it's 8 to 4, and you reduce it 2 to 1, and then the last one, DA is in a ratio to HE, and it's 10 to 5 and 2 to 1. So for these to be similar, angles have to be congruent, all that's got to be the same, and all the sides have to be in the same ratio. Like if two of these were 2 to 1 and one of them was 3 to 4, it's not similar. They all have to be in the same ratio. Okay. When you write these, the order that you write them makes a difference. Since these are polygons, this is what they call the similarity statement. If I write it in this order, polygon A, B, C, D, and use the symbol is now this little curve, tells you that it's similar. Now, if I put A first, then it has to be similar to E. B is congruent to F. C is congruent to G. And D is congruent to H. If I wrote this E, F, G, H in a different order, okay, I'd have an error. Okay, that makes sense? So connect these a little bit, like A is similar to E. B is similar to F. C is similar to G, and D is similar to H. And it's cyclic. If I wrote this A, B, C, D in a different order, if I wrote this, let's say C, D, A, B. Okay, I can do that. Okay, but now C is congruent to G, H, E, F. And that's correct. They have to be in the right order. Okay? Okay, and you could also write all of these are similar. You could write like BC to FG is in a ratio CD to GH. They are all DA to HE. You know, you get the idea. I think I left one of them out. AB to EF. And they will all reduce down to 2 to 1. Okay? You know, as long as they all have the same ratio. Okay? Okay, the next thing the author defines is a scale factor. You already worked with scale factors on today's assignment. When you said x is a common factor, and then you multiplied to find the perimeter, okay, you were using the scale factor. It is the ratio of the lengths of the corresponding ratio of the lengths of the corresponding sides of two similar polygons. When I said these reduce to 2 or 2 to 1, the scale factor is 2, okay, on this one. Okay. Now, they might draw them in a little bit different order. Let's look at another example. Say this is example 2. Draw a right triangle. Looks like this. And label this as A, B, C for the right angle. AB is 12. BC is 6. Let's label angle A. This angle is 30 degrees. What's that make angle B? 60, right? Because they have to add up to 180. Or if this is a 90-degree angle, these two are complementary. They add up to 90. So 6, these two, this one and this one, have to add up to 90. Because if this is already a triangle has 180, and if we've already used up 90, then the other two have to add up to 90. Okay, label AC is 6 radical 3. Okay. Okay, now they can rotate these. They don't have to look exactly alike. Okay, let's say I rotate this and I make it smaller. Okay, and label this is my right angle up here. Label this angle, right angle is F. Label this as E. Label this as D. Okay, this angle is 30. This angle is 60. F, the ED, the hypotenuse is 9. The side opposite the 30-degree angle is 4.5. And this one is 4.5 radical 3. Okay. Okay, now, in order, I would write down what I think is the similarity statement. So if I write down triangle ABC is similar to, A matches up with which angle? D. B matches up with which angle? E. And then F matches up with C. Okay? Okay, now once you have the similarity statement, okay, and I don't know that this is true yet. I need to test it. Okay, but once you have that similarity statement, then it should be easy to check. AB to DE, they have to be in order. So if I'm checking AB to DE, check that ratio. AB is 12, DE is 9. Reduce that. 4/3 or divide it out. What do you get? 1.333, repeating, right? Okay. Now, if you've written it, then BC has to be similar to EF. So BC is similar to EF. BC is 6. EF is 4.5. 6 divided by 4.5? 4/3 or 1.333. Okay, and then the last one, CA and FD. Okay, CA is 6 radical 3, and FD 4.5 radical 3. What's radical 3 divided by radical 3? 1, right? And you're back to 1.3. So, is it true that these are similar? Are all the angles congruent? Are all the sides in the same ratio? Yes. So it's true, these are similar figures. That's how you tell if they're similar. They have to have congruent angles, and they have to have sides that are in the same ratio. And what is this 1.3 called? That's the scale factor for that problem. Okay? Okay, last thing in this section is a theorem. 7.1. Okay, theorem 7.1 says this is called perimeters of similar polygons. Okay, keyword perimeters. We're talking the distance around. Okay, the perimeters. If I didn't write that very good. Hang on. If two polygons are similar, okay, so let's switch. Let's use this symbol. If two polygons are similar, then their perimeters now what would you guess? Right, exactly. Okay? If this ratio of every side is 1.3 to 1.3, 1.3, then all these perimeters, the ratio of this perimeter to this perimeter is in a ratio of 1.3. Okay? So their perimeters are proportional. They have to be. The perimeters are proportional to the scale factor between them. So if I know one of the scale factors in two similar figures, then I know their perimeters are in that same ratio. Whoops, hang on, I wrote the wrong word. That should say between them. Okay, that should get you started.